All right, here is problem 14.5.32. Let's see, let's just jump into it. Consider the following set of ordered pairs. It gives us the ordered pairs, gives us the regression equation, and the sum of squares error. It wants us to test it, determine if the slope is not equal to 0. So the first thing we have to do is state the hypothesis. So if we're stating that the slope, if we're testing that the slope is not equal to 0, remember, so that means our null hypothesis is that it is equal to 0, and our testing or our alternative hypothesis is that it is not equal to 0. All right, so now we have to calculate the test statistics. So to do that, I'm going to go ahead and export this to Excel. So there's our data set. And again, I from the book, I found a formula, so I'm just going to paste it in here to make our work easier later. This is the formula for finding the t-test statistic. And so in order to do that, I'm going to need some additional information. So if we look at the book, it's going to tell us the definition of each of these things. It's going to tell us that B1 is the sample regression slope, and beta 1 is the population regression slope from the null hypothesis, and then the SB is the standard error of the slope. So those are the three things we need to figure this out. So I'm just going to call it sample R slope, sample regression slope, and then population R slope, and then SB for the standard error of the slope. And that's going to find us our t-test statistic. All right, so let's figure this out. First of all, let me bring the problem back up. All right. So our sample slope, if we want to, it gives us the information right here, right? So that, but we can also use Excel and do data analysis, and then we'll choose to do a regression analysis. Our Y range will be these Y datas, and our X range will be the X data. And then we have to tell it where we want to output this information. I'm going to tell it right here. Okay, so you can see that like my slope is always this X variable right here. And that was actually, if we go back now to the problem info, we can see it given to us right here, 0.786. Okay, but the reason I did this is because it's going to have some other data that's going to be helpful to us. All right. So our sample slope is this one right here. That's the slope of the sample data is another way of putting that. I'm going to say this equals that. Our population slope is from our null hypothesis. So our population slope is 0, right? Because our null hypothesis is that it is equal to 0, and then our alternative is that it's not equal to 0. And then our standard error of the slope, so there's a formula and we can calculate that, or we can look right here, and one of these columns is standard error, and then the standard error that goes with the slope is right there, and that's actually the number. So we don't have to do another calculation. That's why I went ahead and did this little regression analysis. All right, so now to find my t-test statistic, it's really as simple as saying the sample regression slope minus the population slope over the standard error of the slope. There's our t-test statistic, 6.82. I think they just want 2 decimals. All right, so now it wants us to define our critical values. So this will be our critical t. That's going to be plus or minus the t alpha over 2. So critical t is just going to be, well, you know what? I left out some data. Remember what I always tell you, which is start with what you know. So we know our alpha is 0.05 for this problem, and our n is the number of ordered pairs. So n is 5, because we're going to need that to find the critical t. So equals t dot inv dot 2t, where probability is the alpha. And remember, we don't have to divide it by 2 because we're using the dot 2t formula. And then our n, our degrees of freedom is n minus 2. Whoops. So there's our critical t. Put that there. And because this is a two-tailed test, our critical value is actually plus or minus that, right? So we can say negative 3.18, how many 3 decimals? 3.182, comma, positive 3.182. All right, so now we're supposed to state our conclusion. So we see our test statistic was a positive 6.82. That's way, way, way to the right of our mean on our t distribution. It's way past the critical t, which means what, right? That's what they're asking us to consider. So remember that our null hypothesis was that b or beta, okay, equals 0. And so if that were true, then our test statistic would be no further away from that mean than the critical t. But it's way outside of that, meaning that it's very, very unlikely that our null hypothesis is true. So we're going to reject the null hypothesis and say that there is sufficient evidence to conclude that the regression slope is not equal to 0. And there we go. So again, as always, if after watching this you still are confused or need help, or maybe you're not confused at all, but you just want to talk about it, let me know and we'll find a time to get together and talk about it.